Hello everyone, welcome to Grade 12 Physics AP, Mastering Kinematics in Minutes. In this video, I am going to go over a specific type of kinematics problem, which is the projectiles. So what are the specifics for projectile problems? Well, projectile problems, you need to know that it's movement in a two-dimensional plane, which means that it has both vertical and horizontal components, and you need to split the problem as such. So you need to also remember that there are no horizontal acceleration, and vertical acceleration is again due to gravity. The formulas and the variable used are all the same as the kinematics problem before. However, now you have to have values for variables two times. What I mean is you need all of the five values for the five variables in the horizontal, as well as the values for the same variables in the vertical. I'll show you in our sample problem. The problem: a missile is shot on ground level at a velocity of 50 meters per second at an angle of 45 degrees above the horizontal. How far does it travel before hitting the ground level? So now let's see what we have as information from the problem. So as you could see, we have the initial velocity. However, it's at an angle at 45 degrees. So we can take out and put it as horizontal and vertical by using cosine 45 degrees as for the horizontal and sine 45 degrees for the vertical. Now we don't have the final velocity, which we don't really care. We have acceleration, which horizontal we all know it's 0, and vertical we all know is due to gravity, and it's pointing downward, so it's minus 10. And for the displacement, we know that it's from ground level to ground level, so vertical is 0. And we need to find the delta x for horizontal. So if you see this, we have to solve for the delta x for horizontal, but we only have two variables for the horizontal, and we can't really solve this problem. However, we do see that in vertical we have three variables, so we can actually solve for all variables in the vertical plane. Now, so how do we tackle this problem? Well, the common variable in this scenario is going to be t, because time in which when it reaches ground level from vertical would also be the same time of the displacement that we need to find for the horizontal plane. So our strategy is to solve for the t variable in the vertical plane, and then we use that same t variable to find the delta x on the horizontal. So let's see our solution. So if we use the delta x equals to v0 times t plus half times a times t squared formula with the vertical plane, when we fill up the values that we need, we would have 0 equals 50 times sine 45 degrees times t plus 0.5 times minus 10 times t squared. So if we were to redistribute these values, we would see that t equals to 7.07 seconds. Now we know that the time would be the same for horizontal, so we can plug this time back in to the horizontal, fill the information that we need to find out delta x. So we could use the formula again, and we substitute these with 50 times cosine 45 degrees with the initial velocity, and the time, which is 7.07 seconds. Now, because acceleration is 0, we don't care about the half at squared part, just to minimize the math. And in this case, our answer would be 249.96 meters. And thank you for listening to our video. This concludes the lecture. If you are interested in more studying materials, please download our physics app and other AP course study apps. This can be found in the links in our video description through YouTube. Also, if you want to keep up to date with our latest videos for studying purposes, please subscribe to our YouTube channel, and please share our videos via Twitter and Facebook. Thank you.